Hi, welcome to my tutorial. This video will focus on how to solve numerical problems on z-scales. That is, the determination of areas or the probability, or we'll call it the proportions, under the normal distribution curve. I'll focus on the determination of the probability or the proportion under this normal distribution curve. Please pardon my curve as this is a freehand sketch. It is not that accurate. Thanks for your understanding. Now let's look at the challenge we have on the board. 2000 femur bone length of a species of cow is normally distributed with mean 60 mm and standard deviation 10 mm. The question says, what is the probability of selecting at random a bone? This is another way of saying what proportion of bone length is greater than 66 mm, less than 66 mm, between 60 mm and 66 mm, measuring between 66 mm and 77.5 mm. Next question says, out of the 2000 bone lengths in the population, how many are larger than 66 mm? Please note, if graphically plotted, all normal distribution assumes a bell-shaped curve, just as we could see here. These curves are sometimes called standard curves or the normal deviate, and it tells us how many standard deviations from the mean the particular value of x is located. Mathematically, the z-score is x minus mean divided by standard deviation. We are given the mean value to be 60 mm, while the standard deviation is 10 mm. It is worthy to note that the total area under the normal curve is 1 or 100%. This simply entails that dividing this normal curve into two equal halves, from the middle value here being 60 down to 30 will be 0.5 or 50%, while the remaining area of the curve, that is from this point to this point, is also 0.5 or 50%. This agrees with the theory which states that all normal distributions are symmetrical. This means that half of the area of the curve starting from 60 down below is 0.5 or 50%, and from 60 to 90 is also 0.5 or 50%. Of course, adding up the proportions, 0.5 plus 0.5 gives 1, being the total area, or the probability being 50% plus 50% gives 100%. In our question, the population of the femur bone length is 2000. This simply means that half of the population, that is 1000 bone length, is larger than 60, and another half is smaller than 60. The first question asks the proportion of bone length or the probability of selecting at random a bone that is greater than 66 mm. So we determine the proportion that is greater than 66 mm by substituting 66 for x in our formula. Here we go now. So we have 66 minus the mean value being 60, and then divide by the standard deviation value. And so 66 minus 60, and then divide by 10, 0.6. So our z value is 0.6. Now to determine the proportion of the population of bone length that is greater than 66 mm, we'll visit the proportions of the normal curve tables. Here we go now. So this is the proportions of normal curve table. And remember, we got our z value to be 0.6, and the value is 0.2743. So we record it here. This is read as the probability of x greater than 66 mm or the probability of z greater than 0.6, and that gives us 0.2743. We could express this as a percentage by simply multiplying by 100. So this value multiplied by 100 gives 27.43%. So from here, which is greater than 66, so this part is 0.2743 or 27.43%. Now let's proceed to the second question. Second question says the proportion that is less than 66 mm So the proportion that is less than 66 millimeters is from this point below. Remember, we did say that the total area under the normal curve equal 1.0 or 100%. So if this total area gives 1.0 and the area that is greater than 66 millimeters gives 0.2743, that means the area that is below 66 will be 1.0 minus 0.2743, and that gives this value. Or we could say 100% being the total area minus 27.43%, and that gives 72.5%. So the probability of an X less than 66 millimeters equal 0.7257 or 72.57%. Next question is the probability or the proportion of bone length that is between 60 millimeters and 66 millimeters. Of the total population, half lies below 60 millimeters, that is 0.5 lies below 60 millimeters. If we go by substituting 60 into our formula, we have 60 and then minus our mean value is 60, then divide by the standard deviation value. So 60 minus 60 gives 0. 0 divided by 10. Now let's visit our proportions of normal curve table to determine the probability when z equals 0.0. This is our table. When z is 0, the proportion is 0.500. Also, 0.2743 is greater than 66 millimeters. So the proportion that lies between 60 millimeters and 66 millimeters will be 0.5000 minus 0.2257. Multiplying this by 100 gives 22.57%. And this is read as the probability that X lies between 60 millimeters and 66 millimeters. So from this point to this point, that is the point shaded with green, is 0.2257 or 22.57%. Next is the probability of selecting at random a bone measuring between 66 millimeters and 77.5 millimeters. So we are looking at the proportion that lies between 66 to 77.5 millimeters within this area. Using the z-square formula, remember the probability or the proportion that X is greater than 66 millimeters gave this value. Let's also use the z-square formula to find the probability that X is 77.5 millimeters. X value is 77.5 minus the mean value and then divide by standard deviation value gives 1.75. Let's visit our proportion of normal curve table where we'll find 1.7 under 5. The z is 1.7 and then under 5 we have 0.0401. So subtracting this value from this value gives, this is read the probability of selecting a bone that lies between 66 millimeters and 77.5 millimeters. That is the probability that z lies between 0.60 and 1.75. So from this point to this point gives this value. Now let's move to the next part of the question, which says out of the 2,000 bone lengths in the population, how many are larger than 66 millimeters? Remember, the proportion that is greater than 66 millimeters is this value. So multiplying this value by 2,000 being the number of bones in the population gives, so 549 is the number of bones that is larger than 66 millimeters. Please like if you found this video helpful. Comment with any questions or topics you would like us to cover in future videos. Share this video with anyone who might find it useful. Thank you for watching. Do not forget to hit the notification bell to stay updated with our latest content. See you in our next video. Bye.